Hi, this is Eric Sloef at the VMworld 2013. I'm at the Solutions Exchange and I'm joined by Frank Denneman. Frank, how are you?
I'm fine, how are you?
I'm fine, thanks. Frank is working for PernixData, and PernixData has a real cool product. It has to do with flash and write cache and read cache. Can you exchange a little bit what PernixData does? Is it a device or is it just software?
So PernixData FVP virtualizes server-side flash into a clustered solution that offers read and write acceleration of the virtual machine IOs. So it's a kernel module extension. So it installs in the kernel module and it clusters all the hosts that runs FVP into a single flash cluster. So we can drive through the UI if you like to see how we install.
Yeah, that would be great. Show us a demo, please.
Okay. So what you need to do is you start off with installing the kernel module. So you can use the CLI or you can use Update Manager to install the VIP. Then you basically select the cluster, select Create Flash Cluster, type in a name, let's say VMworld TV. So then we say Add Devices. I have to click on it first. So here we have all these flash devices in the ESX host itself. So we select a Fusion IO card in one host, we select another Fusion IO card in another host.
What we see is local flash storage in the ESX host,
yes.
And you're just selecting it, attaching it, but I can imagine if a host goes down, you will also lose that local flash storage. How do you cope with that?
Yeah, so this is the beauty of having a clustered solution, right? So what we do is we track the flash footprint of each virtual machine. As we are in the kernel, we actually know the virtual machine identity and all the I/O it belongs to. So I can continue where I can show you. So we just added the devices. So the next thing we do is we add virtual machines to accelerate. So this is where it comes down to, right?
So you create a policy per virtual machine, and for an individual machine, you're selecting flash storage.
Well, you don't select flash storage, that's the beauty. You just select the virtual machine, as you can see, and then we select the write policy. We can select write through, or we can select write back. And the moment we select write back, we accelerate both reads and writes.
So is that the only product what really does write back right now?
Yes, exactly. We're the only clustered solution that does write back. The beauty of cluster solution is that we support every vSphere clustering feature, like HA, like DRS, link clones, whatever. It just uses it. So to continue with the write back, we just select the write redundancy. What that means is we can say, I want to store all my writes on the local flash device and a neighboring device. If that host crashes, that host, the virtual machine, or the data store connection fails, or the flash device fails, the other host that hosts the replica data understands, due to FVP clustering solution, that, hey, that host is down or is not able to write through the array, I'm going to do it for you. If the host fails, for example, HA is going to restart the virtual machine on another host. That replica host is going to destate it first. We're going to hold the virtual machine until it's destaged completely. So when HA restarts the virtual machine, it has all the data on the array itself.
Okay,
right?
Great. So can you show us how to finish this setup?
Basically, we selected write back, local flash with one network device, and we're done. And this virtual machine now is accelerated. That's that easy.
It's pretty cool. Can you show, I can imagine that you just added the data store, so there's not a real history of performance,
yeah.
But can you show how an administrator can see if it's really accelerated?
Okay, so what we can do is, maybe we have, in the demo cluster, we have something running. At this point, we only support the vSphere client. We're working on a web client solution, of course. Well, what we can do is, we can go to the PernixData tab, and I've totally selected a virtual machine. Maybe.
And selecting a virtual machine gives you an insight into that individual virtual machine and the performance of that particular virtual machine. So it's a per virtual machine policy, and you don't have to select a whole data store that's going to be using SSD, for instance.
No. And it's not a persistent data store layer. So it's not that you need to reconfigure the virtual machine and to storage motion it to that data store. We don't. You don't see it. It's only the flash cluster in the UI, and then with performance graphs, you can see the IOPS, the latency of the network device, the latency of the flash device itself, the latency of the data store.
So the intelligence is really embedded into the kernel, and every write and read action is intercepted by the software and rerouted to the SSD.
Correct. So what happens is when a virtual machine is issuing an I/O, FEP is deciding on what to do with it. Can we serve it from local flash? Is it stored on a remote flash device? Because DRS might move the virtual machine, right? So we're not losing the flash footprint, we just retrieve it from another host. Then we copy it into our local flash device, so the next time you read it, or whatever you want to do with it, we can serve it from local flash. Right.
Okay, great. What's the use case? Is it specially targeted at view environments, or can I also host SQL or Exchange on it?
Yes, everything. All virtual machines, every I/O we can accelerate. It's because it's part of the kernel, the I/O travels through the kernel, we just basically can accelerate it for you. Right?
Great. So, to conclude the demo, do you want to show us something else, or?
Yeah, I was trying to get the performance graphs, but just because we just destroyed the whole flash cluster for you, we don't have any. But just let me grab some UI bits.
So you can see the virtual machines, you can see the original hosts they're running on, the policy that is configured per virtual machine.
Yes, and I'm trying to get the virtual machine. So one of the cool things is the hero numbers, as we call it. You can see the flash cluster, and you see the IOPS, the throughput, and the latency. Just because we just started it, it's just accumulating data. But in the end, at one point, you will see how much data you saved from going all the down to the array. So this is another cool part. Because you selectively can accelerate virtual machines, what it means is you're saving a lot of used bandwidth to the array. So other virtual machines who are not accelerated actually take advantage of it as well, right? The bandwidth is less used, so other virtual machines can use it more. So what happens is most virtual machines, if you accelerate the proper ones, other virtual machines will benefit from it as well.
Okay, that's great. Cool, many thanks for the demo, Frank. It's an awesome product. One more thing, you are the initiator of the vSphere Design Pocketbook. Is it going well? How many copies did you hand out, physical and ebook versions?
I haven't tracked the ebook, but those are, because everybody can sign up for it, it went crazy. But in VMworld US, we gave away 1,500 books. And in this at Europe, we have 500 books. So if you want to have a book, please swing by and grab one.
So if people want to have a copy of this book, maybe signed by you, they have to go to the Pernix stand or go to the Pernix website?
Yes, for the hard copy, they have to swing by the stand. And if I'm at the stand, I will happily sign your books. There are other people. This is the beauty of this book. It's not me. It's basically a platform for all the community. So there are a lot of people in this book who actually provided real nice knowledge. And I'm looking at somebody really famous. Let's see if I get it. It's the name of Eric Slove, but yeah.
I'm in the beginning.
I mean,
the host.
which page? Because, right? You know which page you are.
I didn't learn the page from head.
Look. So when you are sizing a host, memory and CPU are important, but also take a look at network bandwidth and storage bandwidth, right? It's really interesting. It's done by Eric Slove. People like you, people like me, everybody who wanted to contribute could contribute to the book. So it's a very valuable book for the community, by the community.
Great, many thanks, Frank.
Many thanks for this interview.